Go. You want to go? Whenever. Alrighty, it's just about 2, so I'm gonna dive into this. What's up, folks? I'm Michael Weber, and I'm here to talk with you today about offensive browser extension development. But first, who am I? I'm a security consultant for NCC Group. I am not affiliated with Red Hat. I just like this hat. I also like to break things from time to time. That stems from the fact that in a previous life, I was on the defense side doing malware reverse engineering until I got so frustrated with it that I decided I would try offense for a little bit. And it's actually a lot of fun. I'm pretty into it. It's good stuff. Also, my name is a little common, so I have to clarify. I am not Mike Weber from Coalfire. I am not Michael Weber from Aspect Security, which is now owned by Ernst & Young. I am not Michael Weber from the cybersecurity area of Lockheed Martin. There are many of us in security. We are Legion. If any of you are here, I'd be happy to do some like Parent Trap style, like switcheroos. Maybe we live each other's life for a day or two just to see what happens. It'd be cool. But anyways, we're here to talk about browser extensions and what they are. And if you do a Google image search for browser extensions, you're going to get like the smiliest puzzle pieces that you've ever seen, like dozens and dozens of puzzle pieces, which is kind of the shared nomenclature we have for plugins. And it's important to note these aren't quite plugins. There's really only one plugin that runs for your browser these days, which is Flash. You can't compile something in C++ and then just have it interact with your browser anymore. Instead, what we've got are these extensions, which can extend and modify the capability of a browser. That's the official definition. I find it a little weird to use the word to define itself, but that's how they describe it. In practice, I think that they're like a catch-all bucket for functionality that we need to kind of just like hack on top of the browser. It provides a lot of extra functionality that the browser has available to it and then makes it easy for everybody to use. Users install these things from like a browser-specific storefront, or you sideload them. Though it's kind of less common to sideload things now. The number one way that all of the providers want you to handle this is they want you to install it from a store. So the way that all of this is actually written is a bunch of the powers that be they reached a consensus on what shared behavior should be in browsers, and they've exposed that in the form of what they call the Web Extension API. And this is kind of a shared API that's implemented in part by Chrome, Edge, Opera, and Firefox. It exposes just a little more functionality than you get in your average web application. The way I like to describe it is imagine that you've kind of got like cross-site scripting for every website that the browser can touch, and you also have no CORS policy. So it's kind of like a supercharged cross-site scripting. I think it's really neat. And the way that you write these things, it's entirely in JavaScript. So like everything that's on the web these days, JavaScript, 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 everything's a web application, and that's how you write extensions too. Also, given that we're here in a red teaming context, I do have to say, there isn't exactly the easiest way to execute shell commands, though I saw that there's a talk in about 2 hours, which is going to tell us how to do that with JavaScript, so I'm really excited to see that, because that will charge these things up even more. It is worth noting there's something called native messaging that extensions support, which will let you do shell execution, but you need to have already been on the box, and we'll talk about that later. So different browsers will implement this functionality slightly differently. Like there's no real totally shared API. So you can go to the Mozilla webpage and see these big graphs of like, oh, Chrome does this, and you know, Edge does this, and you know, we all support this API. We've supported since different versions. It's just, you know, it's worth noting not everyone does it the same. Chrome sometimes goes above and beyond and implements way more stuff in the form of applications, but that's been discontinued, and there's no way that you can create your own applications now, or is there? And the reason that any of this matters and that you're here is the way that you install this turbocharged cross-site scripting requires 2 clicks from the user. That's it. You need to go click on like add to Chrome or add to Firefox. You see a pop-up, and then you just hit add extension, and you're good to go. This is kind of a less challenging thing for users to do than say, I'm going to double-click your executable that you've mailed me, or run this Excel macro, and users just aren't quite as aware that maybe they shouldn't be doing this. And the reason for that is the place that you do this from is these trustworthy sites that are run by Google or Mozilla. You're on a site explicitly by a provider that made their browser. So it makes sense that they're going to want to trust it. The only trick is in order to get your extension onto this delightful storefront, you need to get through the approval process. Once you've done that, though, anything that your extension's doing, it's coming from inside the browser. So, like, there's nothing unusual about seeing Chrome open a TCP connection to connect to a website. That's just something you're going to expect to see. So a lot of endpoint detection solutions are probably not going to be keen as frequently on what you're doing if you're an extension inside the browser. AV tends to give you a pass. And because of this browser extension API, they are actually multi-platform. I know I just went on about how everybody's different, but in practice, I've found that you can write a Chrome extension to target a specific user, and then I've actually found out on gigs, oh man, my target actually uses Firefox. Poop. So I went through and saw, well, how easy is it going to be for me to take my extension and publish it to the Mozilla add-on store, and it took 30 minutes. The reason for that is that, like, they allow you to take the same syntax you write a Chrome extension with, which is you say like Chrome web extension API, so Chrome.web request, or Chrome.cookies, or Chrome.whatever, and Firefox will also read that. It's supposed to be browser.whatever, but everybody kind of wants to make sure that it's easy to import a Chrome extension, because that's the #1 market share. And malware authors know that this stuff is really juicy, so they've been abusing this for quite some time. I think there's even more possibilities, though, in a red teaming context, and we're going to talk about that. But before we do, I think we have to talk about the prior art, which is malware. Malware is great for this. For example, there was a malware family called Catchall, where after you ran their executable, it was a normal, conventional, like download and run my executable, they would sideload a Chrome extension which would intercept every single post request that you had and then ship that back to a C2. So every time you logged in or used anything that might have a credit card number in it, that information got beamed right back to them. And the way you used to do this was you would manipulate the Chrome shortcuts. So you would change the user's Chrome shortcuts to immediately load an extension and disable a bunch of warnings. And that worked for a while, and then Chrome understandably said, this is kind of unsafe, we're not going to let you do this anymore. So in your current versions of Chrome, you can no longer just say -- disable warnings and have everything work. Unsurprisingly, we've also seen this in the banking sector. I call this one out specifically because I think it's worth noting on that right over there, that's what the store page actually would look like for someone that was going to install this extension. This is what they'd see, and then somebody would actually click that and install it. I mean, you have to do a little bit more than this these days. It's a little harder than just having no screenshots whatsoever and calling yourself interface online. But fundamentally, this is all you're contending with. It's a small social engineering challenge for you, essentially. And sometimes this comes out in fun ways. So you can take an existing extension that does something benign, for example, Mugle, the custom logo for Google extension, which was also an ad fraud proxy. And it was awesome, because it would normally be benign until it got a configuration update, which said, oh, by the way, I need you to also hit this ad so I can make some money. And that was quite successful. And then finally, my personal favorite, because you can't have malware without any sort of cryptocurrency getting involved, which was the FaceX worm. And this would spread through all of your messenger contacts. And then once you installed it, it would intercept all of your post requests to crypto sites, jack your credentials, and then to add insult to injury, it would also use you to mine cryptocurrency, because it's not bad enough that I got your coins, I also need another 20 cents a month, which I just, you gotta get that value out of your malware. But I think that you can do more with this. It's nice that we can do ad fraud. That's a great thing, but simultaneously, we also have access to every internal resource that user has access to, and we can hit it with their cookies and their local storage. The browser's already going to do that. I actually have a colleague who wrote a really cool cross-site scripting proxy as a POC that, hey, once I get cross-site scripting, I'm going to be able to connect to all kinds of things on your behalf through another browser. We can take something like that and then turn it up to 11, because now it's not just on the site that we're on, it's on all the sites. So we can enumerate internal DNS. I might not know that you have a Jenkins installation, but if I start looking for Jenkins.whatever and it suddenly returns me a website, I know you've got it, and I can hit it. We can access local host developer resources without needing to do fancy DNS rebinding attacks. IP whitelisting is no good because the call's coming from inside the house. And sometimes you can even access the file URIs to read files directly off disk from the browser. And that's disabled by default, unfortunately, but there's some stuff we can do to fix that, and I'll go into that later. Obviously, as you saw in all those malware examples that I gave, we can also man in the middle all of those communications that we get, so we can jack credentials from people. You even actually used to be able to intercept and modify traffic that would go directly to Chrome's internal pages. So there was one malware family which would say, oh, it looks like you're trying to go to Chrome extensions. I'm going to send you somewhere else so you can't actually uninstall me. And it would send you to a page that looked like this and would say, ah, sorry, it's corrupted. I guess you're just going to have to live with it. Yeah, and no, it was a clever usage. Unfortunately, it got a lot of press, or fortunately got a lot of press, and Chrome no longer lets you intercept this functionality, which you'll kind of notice is the theme for a lot of the things that we're going to start talking about, which is it used to be possible, and then it got overused and is no longer possible. But don't worry, there's still plenty of fun stuff for us, so we're fine. So let's actually talk about writing some of these bad boys. The basic extension structure is not that much. Really, all that we need is a manifest JSON file. That's pretty much what contains everything. That's going to point at all the other files. So in practice, you could have an extension that's like one JavaScript file and a manifest file, or you could have like tons and tons and tons of stuff. That's probably what you're going to see in a real extension. The reason that we care about the manifest JSON, though, besides the fact that it says what's going to run and what content is there, is it specifies what permissions our extensions actually need to run. So, for example, if I write an extension that I want to use Facebook Messenger, I need to explicitly say I want to be able to access www.facebook.com in my manifest. But what if I also then want to have, you know, my ad click revenue? Now I need to add Google Ads, and maybe I want to pull a configuration down from somewhere, so I pull something else and I add another thing, and suddenly I've got this big long list of URLs. And as a result of that, it's possible to specify wildcards, which let you request everything. And you can probably take a guess at where that's going to lead for your average developer who writes extensions. In addition to that, we also need to specify stuff like, you know, do I want to touch cookies? Okay, great. I'm going to request cookie permissions. History permissions. I'll go into a list later. And depending on what permissions you request, it will affect what warning window that you get when somebody tries to install stuff. So that second window that pops up is based on what permissions you request. So here's an example manifest JSON file. This is all that you need in order to say, okay, that's great. I want to man in the middle all of your traffic. I want to steal all of your cookies, and I want to be able to proxy all of my traffic through you. It's not really that much. We really are just looking for 4 permissions here. It's not too much. And you might be thinking, well, surely the permissions warning that pops up is going to tell us, you know, there's no way you should install this extension. But the answer is, it kind of looks something like this. This is all that you need in order to man in the middle all of the things. It does say you need to read and change all of your data on the websites you visit, which sounds scary as all hell. Like, that's really bad. And it means exactly what it sounds like it does. Unfortunately, if you go to the front page of the Chrome Web Store and just look at like what free apps are available there, you're going to find that that permission is requested by a huge number of applications. I've highlighted in red on this image here every application there which requests enough permissions to do all of that bad stuff we were just talking about. It's a good number. It's a very common thing that happens. The reason is that users are effectively desensitized to this permission warning. Like, the first thing you go and install when you get a browser is you're going to install some kind of ad block, which makes sense because, you know, who wants to go browse the internet without an ad blocker? And that's going to require the ability to intercept all of your communications and then modify them to remove all those pesky ads. So developers in practice know, I don't really need to specify Facebook.com and exactly what I'm touching. I'm going to specify a just wildcard set, and that's going to be fine. Some permissions also won't even tell you or change the permission warning. So like if I request cookies, that box doesn't change because it's considered, maybe not that big of a deal. So you can sneak a lot of stuff into an extension without it really making a difference to the user. And Google's aware that this is a thing. So in the tradition of all talks, like 4 days before I was going to give this, Google had a gigantic announcement about how they were going to change the trustworthiness of all extensions. And they came up with some good fixes, I think. So they're going to allow users to explicitly whitelist specific sites when you go and request wildcard permissions. So I might say, okay, that's great, you can have all the URLs, but in practice, I'm really only going to let you go to like, 1 or 2 sites that I've explicitly whitelisted. I'm a little skeptical that that alone is going to be sufficient because as security people, we know that a whitelist is a great solution, but your users in practice are going to fight before they have to actually accept that. And can you imagine someone installing an ad blocker and then having to manually whitelist every single site that they go to? I don't see that happening. One thing, though, that will impact us, I think, is they've changed the review process. So if you request these more dangerous permissions, you're automatically going to get flagged for a more intensive manual review. So you're going to have to figure out how to get past that if you want these permissions. The APIs that we're going to be using once we've requested them, I'm just going to blow through these pretty quick. You've got web request and web request blocking permissions. That's what's necessary to actually man in the middle of the traffic that you want. You've got native messaging permissions. These are interesting in a more post-exploitation sense because if you request them, you can communicate with binaries on disk and trigger Chrome to run stuff. Debugger permissions, which are interesting from kind of a anti-analysis perspective, because we can set breakpoints on every single line of JavaScript in our app and then just drive people nuts as they try to figure out what's happening. And then a couple of the other permissions, they're pretty straightforward. So like you need to ask for cookies permissions to access the cookies. You need to ask for history to access history. You need to ask for the idle permissions. So you can tell when the user's not using the browser so you don't impact their average use case as you crypto mine. And you've got the proxy permission for situations where we might want to forcibly tunnel a user through a proxy we control so we can also listen on what they're doing, maybe without requesting all of those previous URL permissions that we were talking about. They're still going to have TLS, but in some cases a user might get so frustrated with seeing the warning constantly they might just install the CA or they might not care. One thing I do have to mention, by the way, in talking about the manifest JSON is wildcard permissions allegedly have been identified as something that could be a potentially unwanted product, a really common search string for antivirus. So if you literally have the all URLs or similar requests inside your permission or your manifest JSON file, AV might trigger on that as a signature. And you've got 2 options there. One is don't literally request everything, but that's really where half the fun is because we can't predict what internal resources a target is going to have. And option 2 is you can get a little creative, which is that because these are JSON files, we can use Unicode escapes to just randomly change specific letters. So if they've got a really lazy signature that's looking for literally all URLs, then we can change it just enough to maybe get by. I mean, if they parse the JSON, this is going to be no good. And if anyone actually looks at this, they're going to say, what the heck is this person doing? And it's probably going to look shadier than it's worth to do, but just something I wanted to explicitly call out. What we're going to be doing, and what I'm going to keep coming back to here, is never attribute to malice that which is adequately explained by stupidity. That's like the catchphrase for how we're going to hide all of our malicious behavior. You just have to assume that your extension is going to get reviewed, where we really need to be in these storefronts to get any amount of distribution. So with that in mind, you shouldn't be too indiscreet with your actual bad behavior. Like, don't just infect every installation that you get and cause it to start, dumping cookies and doing all kinds of bad stuff immediately, because you're going to get caught. The best way to make sure that people don't think that your plugin, or your extension, excuse me, is malicious is to make sure that you don't actually have the malicious code in there. Like, there's really not a good way to say, how do I make it look like I'm dumping cookies for a good reason? It's just a rough thing to do. So we really want to push that content down after we've identified that that's a target we care about. But we still need to request the permissions anyways, regardless of whether our bad code is there or not. So we're going to want to have some kind of pretext to make a casual review of our extension, say, oh yeah, it totally makes sense. This guy needs web requests and web request blocking because, I don't know, they want to implement a custom URI scheme, and this is a kind of hacky way to do it. In general, if you look like a bad developer, they're just going to assume you don't know what you're doing more than they're going to assume that you're someone that's trying to pop a company explicitly. And if you don't write JavaScript code, congratulations, you can already look like a bad developer the moment you start trying this stuff. It's super easy. So just as an example, like I mentioned that custom URI scheme before. This is how you would implement a custom URI scheme to say, if you try to go to like DerbyCon : // I'm just going to redirect you to derbycon.com. It's a really, really, there's nothing bad about this. This is totally benign, but you need web request and web request blocking permissions in order to request it. So you can just come up with some really toy usage of the permissions, and then when someone looks at them, they're like, oh yeah, that's why you're doing it, but that's not a big deal. And then later on, you push down the real bad stuff. Another trick for obfuscating without being officially labeled as obfuscation, which you're not allowed to do, is to bundle everything. So there's tools called Browserify and Webpack, which let you take large Node.js or CommonJS modules and just jam them all into a single file for ease of running in your browser. And you can do this with any pure JavaScript implementation. So say you're like, well, I want compression, I want encryption, I'm going to want a couple of functions in my actual payload. I'll just put it into the real thing, browserify that entirely so it's one file, and now I've got like a 30,000 line JavaScript file that I can hide some bad stuff in. And it's going to be really hard for an analyst to really quickly look at that and say, hey, look at what you're doing on line 27,652, as long as I don't get picked up by conventional static analysis tools. Because it's a commonly used developer tool, this is a common approach in a lot of JavaScript applications, it's not going to look like you're trying to do anything shady. But fundamentally what we need to do is within our actual extension, we need to hide what acts as an evaluation because we need to push down some code and have it remotely execute. So if you just put an eval somewhere, that's going to show up immediately. Everyone's going to recognize, oh, look at that eval, that's a problem. But you've got a lot of options because it's JavaScript. This is a super powerful language. We can write eval or we can write constructor, constructor, constructor and pass in the same content and it will still evaluate. There's tons of these like really awesome and silly gotchas in JavaScript. You can go look for any underhanded JavaScript presentation and you'll find all kinds of tools that you can use here. If you put that inside that 25,000 line monstrosity which we just browserified, you're really going to make somebody's day really frustrating if they want to find what you're doing. And then finally, another idea is just you take a previously known to be vulnerable library and then exploit whatever the cross-site scripting vulnerability is inside there, and no one will be the wiser. And a lot of the time, unless you've got some real cross-site scripting hotshot looking at your stuff, it's going to be really hard to tell that as they're looking at this stuff. There's just way too big of a queue for really detailed analysis. And this is just one other point I wanted to make, which is you're not allowed to obfuscate, but you are allowed to minify. And as far as I'm concerned, they're very similar things. I showed this to a colleague, and he said, I don't know why you're using that as your example. That's way too easy to tell what's happening. You just need to use any Silicon Valley darling company and look at how their site runs when you go to page 1, and it will blow people's minds. And he's totally right. It is very possible to make a minified bit of JavaScript like completely unparsable to the average human being, regardless of whether they have tools to assist or not. A final piece, trick which I like is using example code. One of the things you're going to have to do is say, okay, well, I have all these pretexts. I need to like fill out an actual chat application. Where am I going to get this from? And a great place to get it is like my first JavaScript chat client. You can just literally go grab this code, dump it into your extension. You don't even have to use most of it, because think of how you see example code used in projects that you look at. It maybe was the base for what the project was, but most of the code that's in there now is dead, it's not used, there's a lot of comments to explain it, but most of it doesn't matter. And that's okay, because it's example code. This is how a lot of people start. But it certainly doesn't look like it's maliciously creating lots of fluff to hide another eval statement in. But that's what it is for you. So just Google for some application that's roughly similar to what you want to do, grab the example, and then you're good to go. As an added bonus, I'm pretty sure that a lot of these extension stores will do some degree of static analysis to compare different plugins or different extensions. And if you only match with one extension, they're probably going to assume you just copied somebody else's extension and you're trying to perform fraud. But if you match with dozens of extensions, because lots of people use example code, you're probably going to slip under the radar. But what do you use for your actual extension command and control? And this is something that I think could probably be a talk in its own right. You have to keep in mind that reviewers are suspicious about any external calls which download something. This is the #1 way we're getting our payload into the actual extension. But I think that we can hide behind technology that is just so complicated, there's no reasonable way that someone's going to understand what's happening. And the place that I like to hide is something that is called Mobile Backend as a Service, also known as Bos. And it's really good for this. Because what this is pretty much a one JavaScript file include that's supposed to give you functionality like A/B testing and authorization and real-time database functionality. Like you can have like Redis in JavaScript for yourself, and that's just a common thing that people will want, right? And so Google's own Firebase does all of this for us, and it makes for a really awesome C2 channel. For lots of reasons. In fact, the reason I know about Firebase is while I was reading the documentation for how they suggest handling some degrees of messaging, Google explicitly says, in your extensions, you should use Firebase. So I'm pretty sure that this is not going to get you banned or pulled from the web store, as their own documentation says you should totally use this. As an added bonus, it's all over WebSockets. I don't know how many of you have ever had to man-in-the-middle WebSockets. It's kind of a pain in the butt. So it's an added bonus that all of this traffic is just like really frustrating. Imagine a WebSocket connection going to a very trusted entity like Google. It's probably not going to stand out as much as something going to like your own shady C2, which you're running on, who knows where. But Mike, I hear you say, I don't want to have to do all of this. You've just described an incredibly frustrating amount of work to do. And you're not wrong. It takes a good amount of effort to make one of these. But if you're feeling a little less work-inspired, another good option is you can just clone an existing extension. There's people that have already implemented extensions that do all of the things we need to try to pretend to do. There's no reason to reinvent the wheel. So given that most of the stuff that we can find in the web stores already is asking for too many permissions, we can pick one that's doing that, grab the code wholesale, and then resubmit it. We'll need to make some changes. You can't just literally take the extension. You can't say, like, this is my app, and then call yourself My App 2 or something and hope that nobody's going to notice. That's no good. You need to be a little more creative than that, but it's still going to be fundamentally easier than having to deal with writing an entire extension from scratch. The stuff you're really going to want to do is make sure that your code runs on the on-installation and on-startup runtime events, because that's going to make sure that your code always runs whenever the extensions were started or when they install it for the first time. And one of the reasons that I bring up renaming your extension is because it can be kind of hard to see what's the real version of what you're looking for at a glance. The only information you're shown in the stores frequently is stuff like, here's an icon, here's some reviews, and here's a rating for those reviews. And we can fake all of this. This isn't stuff that's beyond our realm. In some cases, stuff isn't even really used that much, but it's still the official thing. So like here we've got this WebEx content sharing extension. It's got 21 ratings. I've got extensions that have more ratings than that I've just created for gigs. It's not that challenging to make happen, but we'll talk about that one in a bit. My main point is that it is possible to clone an extension and people really can't tell the difference. So we're going to have to submit this stuff to a web store eventually, and because it's the easiest way that we can distribute anything that we're going to have. And you're going to need to get your graphics from somewhere, and the more professional they look, the better. Like all social engineering, the more effort that you put into it, the more professional it looks, the more successful it'll be. So you can copy it from somewhere, but make sure you modify that content first. If you just pull an image and some text of what the extension does, there's a possibility that during the initial review phase, they're going to check to see if you've just copied somebody else's extension, and then they're going to search for that in Google or whatever and see, oh, look, that's actually literally the description from this other tool. I'm guessing that's probably something that's been copied because somebody wants to make some extra money or something. Now you're just going to get pulled from the store. Edit graphics slightly, like change the color or tint, something that makes sure that a reverse image search isn't going to take them to exactly where you took it from. Also worth noting, as highlighted by Chrome this week, the policies are always going to be changing, so you have to be on the lookout for it. What worked 6 months ago probably won't work now, or maybe it will. You never know. It's really a roll of the dice, but that's pretty much everything in the field. So let's actually talk about the Google Web Store. When you submit to this, you're going to need a Google account, $5, and a credit card. And it's worth noting that though it's probably not explicitly stated, they probably correlate extensions based off of the credit card you use. So if you register, say, 15 malicious extensions on the same credit card and one of them gets detected, that's a very easy pivot for them to say, oh, look, these other 14 are probably bad too. So you can use prepaid visas, just get a couple of those and go to town. You can set the extension's visibility to private, public, or link only. Link only was my personal favorite because that meant it was published and live. but some random person wasn't going to install it off the store. Remember that bit about like not having to infect way too many people? This makes it much easier. Unfortunately, Google got wise to this, and if you install an extension from a link only, on restart, they'll say, hey, did you really mean to do this? It was probably bad, and they'll disable it. So just another example of Google cutting down on a lot of our vectors for being able to infect people with malicious extensions. Obfuscation is also officially banned, but we've already talked about that. Once you do submit, there's going to be a bunch of automated dynamic analysis. You're going to find 10 to 15 different machines have just installed you over and over again. They're going to change their timestamp to like 2 years in the future to make sure you're not using some sort of default logic bomb or something like that, which is totally reasonable because that's how people used to get by this. They'd say, I'm safe for the first 2 months, and then I turn to an ad hoc proxy. You can actually tell based on their user agents what's probably there because who's using like Chrome that's from 7+ versions ago. It's pretty hard to do that, but that seems to be what all their connections are, but that'll change. It used to be that if you got past the automated analysis, you were live on the store in under an hour. But as I understand it now, when we request these newer wildcard permissions, which we're still going to want, it's going to take a couple of days. So give yourself some lead time. If you're doing this for a gig, don't just say, I can make that extension on Monday and be done by Friday. It's probably going to take a little more time than that. But on the Mozilla side, it's a little bit different. You just need an account. There's no credit card. You don't pay for anything. Similarly, you can flag things as public or private. There's no listing view, but that's pretty much dead anyways. You can flag extensions as experimental. Allegedly, this means that it is less scrutinized because it's experimental. So they put like a little beaker next to your extension and don't look at it as much. So that's a great thing that you should be doing if you just want to minimize as many eyes as you have on your extension as possible. You can obfuscate, but they might be able to ask you for some source code. And they very helpfully run a static analysis tool on your extension and give you the output before you actually push it to be reviewed. And that just looks like a bunch of like warnings and errors of like, oh, look, I found cross-site scripting here, or this isn't good, you need to change this. It's a really great helper because if you don't have any warnings, manual review is probably going to pass you. That's what feeds into the report. It's a bunch of volunteers that go through the Mozilla add-on store, look at these reports, and then say, oh, look, you know, pinged on this, this, and this is a warning. So I've submitted extensions to that store before, and they've said like, hey, man, on line 149, 162, and 411, you actually had some cross-site scripting, and that was actually in the example code which I'd copied for that particular extension. So, you know, it happens. Sometimes we unintentionally damage ourselves because bad development or malicious intent, you can't tell. And I just fixed it, and then they pushed it back out to the store, and it was totally fine. On that note of, like, let's say we're in the store now, we don't want to look like we're some zero review, 0-star extension, because that's pretty much one of the only things that looks suspicious when somebody takes a look immediately. So you can either have some friends and coworkers just install this thing and give you some great reviews, or you can go on Fiverr and pay a dude like $30 to give you 50 ratings, and that works. So, like, it's an easy way to get yourself positioned as I am totally legitimate, because as you've seen, legitimate companies have less than 20 ratings for some of their things. So, Fiverr for the win. Let's say we're now installed, we're in the store, we're good to go, we need to get other people to actually install this stuff. I'd love to tell you about this awesome thing called Chrome inline installations, which was essentially a nice little JavaScript API you could hook into, and then on a page that wasn't the store, you could trigger the extension installation process. It would immediately pop up the permission window, and then people just had to click one button in order to install this stuff. But malware authors abused this so badly that Chrome just gave up and said there's really no legitimate usage for this whatsoever and pulled the feature entirely. So that leaves us back with what we were planning for to begin with. We're going to be social engineering people into actually installing these things. And installing extensions currently, as I understand it, is considered a slightly more trustworthy process than just running an arbitrary document that somebody emailed to me. Because once again, we're going to this nice, trusted web store that's run by Google or Mozilla or Microsoft, and we trust those guys. As an added bonus, Google is actively fighting to maintain this. That blog post, they literally use the word trustworthy in it because they want people to trust the extensions. If you can't trust extensions, no one's going to install them. Simultaneously, every 2 months, we've got a news story about extensions being compromised and being used to like steal way too much stuff. So I don't know which way it's going to fall in the long run, but right now people still trust this more than saying, let me run an executable or give me your creds. So here's a couple of pretexts that we can use. Pretext 1, this is my personal favorite, which is we're going to create or clone a video conferencing extension. And we need to convince somebody from our target to get on a call with us, which is actually not as hard as you would think it is. We just need to dangle a big enough carrot. So say we go on LinkedIn and look at our target and see who's looking for a job. We reach out to them and say, hey, you look perfect for this $250,000 a year job. I just need you to have a quick video conference with the lead developer to see if you're a good fit for the team. I've found that spokespeople for companies are really, really, really jonesing to talk to the media. So if you convince them that you're a reporter from some outfit, they will want to talk with you, and they will jump through hoops for that. And then, of course, the sales team, if you dangle some money in front of them, they're going to do anything for that sweet commish. And they will install whatever you tell them to if it means that they're going to land a job. So once we've gotten somebody to agree to chat with us on our video conferencing extension, we're going to send them an email invite. We're going to ninja invite them to a meeting that's like 30 minutes from now. And it's going to be like, oh, come to my video conferencing thing at like mabooblycom.com or something. And once they go to that, they're only going to have the option to install an extension. That's where we can say like, hey, you're in Firefox, install this add-on, or hey, you're Chrome, install this extension for Chrome, and so on. Don't give them any other options. People will be worried about looking unprofessional if they show up. The age-old adage with social engineering, which is like, set an arbitrary limit and people are going to run through it and succumb to pressure, even though it doesn't maybe make any sense. As an added bonus, video and chat are really great excuses to do WebSocket stuff because nobody really understands how video streaming works. Another pretext we can use is we can pretend to be one of these super awesome security extensions that there are many, many, many of within the store. So just send somebody like a cat picture or something that's really benign but unsolicited. And then when they click on it, you send them a follow-up email and you say, hey, that was an internal security phishing test. Sorry, you failed. You can either take a 1-hour training class, it's mandatory, or you can go install this approved extension and have a guess what people will do. As an added bonus, the security extensions in the store are already kind of goofy. So here we have an extension. It's asking for those dangerous permissions that we all care about. It's by Kaspersky, but what the heck is this? I don't know. I guess it was a low-effort extension. It's probably fraud. No, it's real, actually, because just nobody puts thought into some of these things. So it's not as hard of a target as you might think to look legitimate. And then a final one is an old SE classic, which is, if you don't do this, you're going to lose all your email, or, oh no, the VPN's going down, or, this will make your life easier. Just, make up whatever you want. And then set up this fake, infrastructure extension, have them install it, and then say, okay, it's all good, everything's fine, but now you've owned them. So that's what we want to be doing. What does this actually look like in practice? Let's put it all together. I gotta get out of this. All right, so here we're taking a look at an attacker machine. And as I've recommended, we are using Firebase because it is a delightful piece of technology for all of your C2 needs. And in addition to Firebase, we also have a small Node.js application, which is here to help us manage our clients as they come in. Because when this works, you're going to get so many installs that you're going to need a UI to deal with it. It's just not going to work if you just try to manually handle things. So let's take a look at the victim machine. The victim machine is on a private network we want to get into. That network has Jenkins. This user is logged in as admin to their Jenkins instance. It's a really juicy target because once we can get in there, we're going to be able to pop a shell on that Jenkins box. It's admin, so there's probably source code. There's all kinds of real goodies that you want in a red teaming context. But unfortunately, this is an internal network thing, so we're not going to be able to, we can't just hit this from anywhere. We need to be inside their network. So, if we go on our attacker machine and try to go there, no good. So let's take the conceit that we've managed to successfully social engineer this user using one of the pretexts which we talked about before. So they go to the web store, and they're going to install our extension. This is a live extension. This is really in the store. The names have been changed to protect the guilty. I have no interest in having this stuff be banned, but fair enough. If it happens, it happens. But anyways, what you just saw there, that's it. They're owned. It's over. They're done. So when we go over to our actual little Node.js app, we can see, oh, look, we have a connection. Firebase is helping us track these things because it's a real-time database. And remember earlier when I was saying you shouldn't have your malicious code on the extension or within the extension. We're now going to push down that malicious code that's going to let us do all the bad stuff that we want to do. So let's deploy all of our nasty code, and let's dump some cookies. And real quickly, that is every cookie that is installed in that browser for every website. We just have it. It gets sent back pretty quickly. And that's great. In practice, by the way, when you do this for a real browser, it's going to be like a really large file. You're probably going to need to open it in like Sublime Text or something. This is just from a toy test machine that's never touched anything. But that's not enough, because while we might have cookies here for Jenkins, we can't touch Jenkins, which is why I've written a Python tool which will let us create a proxy which translates web requests into stuff that goes into that Firebase C2, pushes it down to the actual extension, and then makes the request on our behalf. So I'm firing up the proxy here for that client. This is Firefox pointed at that proxy. It's making the request. Firebase is relaying all of these requests here. It's actually quite quick, as we're taking all of our requests, and now we can actually see the internal Jenkins instance from our attacker machine. We're logged in already as admin, too, because that guy's logged in as admin. So we've pretty much already won, but let's say I want his password. Let's log him out. And because Jenkins doesn't have a broken logout process, that guy's cookie is also busted. So let's go back to our victim. And the victim is now going to Jenkins for something. They're like, oh, darn, I'm logged out. Well, I saved my password, so I'm just going to click this button and sign in. And we got him. I don't know if you remember the malware I was talking about earlier, that catch-all that took all the post requests and forwarded it our way. We grabbed that login request, and now we have their username and their password, and we're done. We've got it. We're ready to pivot through the rest of their web applications and their infrastructure and really cause some damage. Oh. So that's great. That's a nice tool we can use for social engineering. But there's a whole other side of these extensions that we can abuse to really up our game. There's a post-exploitation way that we can take advantage of this stuff as well. Say that we were already on a machine through a different mechanism, but we wanted to be capturing all their creds, and we didn't want to be installing a keylogger or something else that might be obvious to AV. This is where there's this thing called Chrome external installs. This is essentially going to let us sideload our existing extension onto that person's machine. All you need to do, depending on the operating system, is write to a file or registry key, literally something that is like the name of your extension. So it's just like your 32-character extension ID. And inside that, you need to put this external update URL to point it at the web store. That's all you do. And then the next time that the user restarts Chrome, congratulations, your extension's installed. You're done. Or it used to be that way, because unfortunately, malware authors ruin things for us again, and they used it too much, and now the user gets a very helpful warning that says, hey, did you totally mean to install this extension? And most users are going to say no and turn it off. And one of the things that you might be thinking, though, is, but we're on the machine. We have RCE. We can do whatever we want. So what does Chrome do when somebody hits enable extension? And what it does is it flips a flag in this thing called a secure preferences file for Chrome, which is stored in the user's local data. So the secure preferences file is pretty much just one big JSON blob. It's been locked down with a bunch of HMAC SHA-256 hashes for individual entries. The key is based off of really machine-specific stuff, like your user account sit in Windows, and maybe they hid like a 32-byte key or something randomly in a random Chrome installation file. People dug into this years and years ago. There's a couple blog posts on how does this work and how do you manually modify this. But as far as I'm aware, there's no public tooling available in terms of saying, well, how do I just like flip a flag here? Or at least that was the case. I have a script which will work for this, and I'm going to be publishing that soon. So in terms of what we're interested in for being able to actually change, here's a couple of flags that might be interesting to you as an attacker. There's every single extension has its own entry, and within that entry you might see things like ACK external, which means I acknowledge that this external hasn't been installed by me. So you flip that from false to true, and we no longer see that pop up when you sideload your extension. We can also do stuff like say, I want you to run in incognito mode if I set incognito to true, or I want to be able to refile URLs if we set that to true. But what about reading and writing files to disk? That's a thing we want to do too, and that's where we have to go to Chrome applications, that whole giant feature set that has long been made a deprecated thing. Unless we sideload these entirely by saying that they've been manually added within the secure preferences file, and then we can unlock all of these APIs, which are really powerful things. Raw socket APIs for TCP and UDP, reading and writing files from disk, SSH clients, HTTP servers, like the world is your oyster. It's really powerful stuff. And unfortunately, they have a very strict CSP policy. You can't normally make an XML HTTP request and just put in any JavaScript code you want. You're going to need to be a little more creative and use those raw sockets. It's a lot of work, so I don't have a good example application that takes advantage of all of these things. But I do have a small piece of advice for how you read and write anything from disk. So there's a permission called the file system permissions. It makes sense. It does what you'd think. And to prevent users from abusing this, or extensions from abusing this, the user is supposed to be notified when they have to interact with the hard drive. And so say that I constantly want to read something from disk, I'm not going to want to re-prompt the user every time. So there's a way to save entries or retain them. And once you've retained this entry, it gets saved into a preferences file that might be important and might be called secure preferences. And it looks something like this. So you can just write your own file entries into the secure preferences file to give yourself read-write access to whatever you want, in addition to all of the other stuff you would do with an app. And then finally, I'm going to have to go a little quick here. Native messaging is the way that we're going to pop a shell. Native messaging is a functionality that essentially lets us say, okay, when I call runtime.connect external, Chrome is going to fire up a different executable on disk. That executable is based off of some JSON file, which is stored in the registry or stored on disk. It's this whole kind of like kooky system. It's not super great for documentation either. But once you have this executable, it's going to read things from standard in, and it's going to write all of its output to standard out. So you can interact with it through these APIs. When you need to have a shell, that's what you're going to want to do. You're going to have to create your own mini shell, which reads off of standard in and standard out, drop it to disk in a post-exploitation context, and congratulations, now you're good. Bunch of effort. We need sample code for that, and that's what this code dump is going to be for. Soon, if you go to that URL, you will start seeing code appear, which is going to make a lot of this stuff easier to do, so you don't have to pull your hair out while you're doing all of this stuff. Stuff that you're going to start seeing pop up in that repo is workarounds for side-loading apps without having errors, because once we're on the box, we should be able to do whatever we want, right? We should be able to make that thing run an extension regardless of whether or not it's in the store. Something that I'd like to think of as a malicious extension cookbook. A bunch of recipes that are interesting for us, like what does it mean to dump all the cookies, or how would I run a shell instantly? As well as some general framework for that C2 I kind of demoed playing around with Firebase. Like, obviously, we can't publish everything there is here because it's going to get detected in the actual store approval process. But in that beyond the approval process, all of the good stuff, I see no reason why that can't be public. Do we have any questions? Can I answer anything for you guys? Yes, man in the red shirt in the front. So, not directly, but once you get disk access, what you can do is you can read the user's like data protection API key to then decrypt the file on disk that has all of their stored passwords, and then you can dump all of them. Oh, yeah, sorry. There's an API for hitting local storage. You can nail all of that. So yeah, that's the thing. There's an encrypted file on disk which you can read. You have to get file reading access before you can touch that. Whoop. Hold on, I've got a guy back there, then I'll get this dude in the hat. Yes. It's every cookie that's stored in the browser. Like, yeah. Whoop. Sorry, you and then you. So that would probably require reading things from disk, but that stuff is right in the same area where you'd expect to see other extensions. So once we can read things off disk, yes, you can. But you're not going to get it purely from just an extension that you don't have any post-exploitation shells on. Yes? So the question was, what about newer extensions that are about like U2F and handling interactions with that? So there are actually this great class of super legitimate security extensions which are supposed to be used for handling like your U2F stuff. If you can convince somebody else to install your own extension instead of that, you can man in the middle U2F all day and start using that stuff to access things you probably shouldn't. I think we're good. Hey. So Android hasn't played around with this much. The thing about it is it doesn't support quite as rich of a feature set in the web extension API from Firefox. But it's absolutely something I keep an eye on because I think that would be interesting to be able to compromise. You do need to publish the Microsoft